This is a lecture video for 8.6. Remember that when you have a lecture video in class that it's going to be tied to a forum. So that means you're going to be watching this video, starting on your homework, and then posting your questions from your homework in your 8.6 forum that's in Moodle. So we're going to go ahead and get started. What we're doing is we're solving equations that have radicals in them. And so when I say a radical, I mean like a square root bar. So let's look at our first example here. It's the square root of x minus 2 equals 3. Now, I want you to notice that everything on the left is under the square root bar, and everything on the right is free from that bar. It's not attached or underneath it. This is how you need to have all of them set up for this to work. The next thing that you need to do is to cancel the square root bar. You need to undo it by doing the opposite of a square root. So the opposite of a square root is to square it. So we're going to square this entire side, and when we do that, they cancel. Notice that I did a square root here, or a squaring it, because this is a square root. The powers will always match for this to work. What I did to one side, which is squaring it, I do the other side, so I also square it. So the right or the left side, they canceled, and this came down. On the right side, I squared it, and I ended up with 3 times 3, which is 9. So now I just have a simple algebra problem where I'm going to do the opposite here to move the 2 to the other side, and I find x equals 11. Final answer. Okay. Computer's being a little crazy for me here. The next problem is going to be x plus 4 is equal to negative 6. Again, we have a problem with the square root. To undo a square root, we're going to square it. Why are we squaring it? Because the powers have to match. What I did to one side, I must do to the other side, and notice that I square everything on that right side. So not just the 6, but the negative 6. So I now have x plus 4 free of a square root because they canceled each other out. And on the right side, I have negative 6 times negative 6. 2 negatives make a positive, and 6 times 6 gives me 36. Oops, that's not a very good 6. I need to move the numbers away from the letter to solve, and so I do the opposite of what I have, so I minus 4 from both sides, and I find x equals 32. Now, what we haven't talked about yet is we have not checked our answers. And the reason I stop here is because this one doesn't work. So we're going to go back to the first one, if my computer will work here. And if I take this answer and I plug it in up here, I now have the square root of 11 minus 2 is equal to 3. Well, let's see. 11 minus 2 becomes what? 9? And the square root of 9 is 3. And so 3 equals 3. So this one worked, right? Because both sides of the equal sign are equal to each other. So we checked our answer to see that 11 worked, and it did. Now, if we go in and check our answer here and take 32 plus 4 is equal to negative 6. Well, when I add these two together, I end up with 36. And the square root of 36 is 6. It didn't give me negative 6. So this does not work, so this is no solution. You're always going to be able to find an answer, but it's checking to see that that answer works. Will either give you an answer of negative 6, or it'll give you an answer of no solution. And in this case, it's no solution because it doesn't work. All right, let's try another one. This one is the square root of 5k plus 1. Underneath that radical, or square root, however you want to talk about it, minus 11 is outside of it, and then it's equal to 0. Remember that in the beginning I told you that all of the numbers that are not under the radical need to be on the other side. So I need to move this 11 to the other side. And I have 5k plus 1 equals 11, and now we're ready to apply the same rules that we've been doing to both sides. And 11 squared is 121. I'm going to subtract 1 from both sides to move the numbers away, and I end up with 5k is equal to 120. I'm going to divide by 5 on both sides to get k all by itself, and I find k equals 24. I would plug this back in and see that 5 times 24 plus 1 underneath this radical is equal to, is equal to a positive 11. And that actually does work because this inside here becomes 121, and then it becomes, you take the square root of it and it becomes 11. So yes, it works. So this is our answer down here in the box. Okay, let's try a different one. All right, I've got 9x minus 4 equals the square root of 8x plus 1. These make students panic, but they shouldn't. You just take care of one side first. Sorry, I was going to change colors here. And I square it because that's what I need to do to undo the square root. And what I did to one side, I do to the other side. And so it just ends up working itself out here. So I bring down 9x minus 4 is equal to 8x plus 1. Remember, the goal is to have x on one side, numbers on the other. So I'm going to subtract 8x to put like terms together. Minus 8x, which gives me 1x. I'm going to add the 4 to the other side. And I ended up with x equals 5. You'll plug it back in to these two places here to check to see if it works. And it does. And you'll end up with 5 being your final answer. Man, my voice is getting worse and worse. All right, next problem is a power higher than a square root. So this is what we have now. I have the 4th root of y plus 1. And notice that if there's no number here, it's understood to be a 2 for a square root. But if there's a number there, then it's clearly a different power root. All right, first thing we need to do is we start working on the left side. And we're going to raise this to the 4th power. Remember, I told you that the powers need to match for them to cancel. And so y plus 1 comes out of that. What we did to one side, we have to do to the other. And this also works. And so I bring down a 2y. We are trying to solve for y, so we need to put together like terms. So I need to subtract y to put it with the other one. And I end up with 1y equals 1. And that's just y equals 1, because 1y is just y. You'd plug it back in up here on both sides to check to see if this works, and it does, and so y equals 1. This method that you see on the board, it works, and you're only going to have problems in this class that have matching powers on both sides. So if this is a 4th root, you're going to have a 4th root on the other side if they're both under a root. Okay? All right, that's all we have for 8.6. Make sure that you start your homework and post any questions you have in the forum. Remember, it's a graded forum, so even if you don't have questions, you need to kind of stretch it to come up with a question, because you do get credit for posting, helping somebody else, or commenting to somebody else's post with a helpful resource, and then responding back to me. All right, send me a text message or an email if you have any questions.